Assalamu alaikum students. Your next topic in chapter 9, physical optics, is Bragg's law, which is another important long question. But before going towards the Bragg's law, you must have to understand what is diffraction due to a narrow slit, what is diffraction grating, and then you will be able to understand the diffraction of X-rays by crystals, which is basically the Bragg's law. So first, if I explain the diffraction, so the definition of the diffraction is the slight bending of light around the corners of obstacles, sharp edges, or narrow slits. So look here, these are the light waves. This is the slit across which the light waves are bent, and they are passed across the next side. So this process is basically known as diffraction. Here also a small opening is represented, and the light waves which are incident upon this small slit are diffracted over here. So this process is known as diffraction. The bending of the light around the corners are through a narrow slit, small opening. So the amount of the bending is actually depending upon the size of the wavelength of the light and the size of the opening. This is if I consider the d is the size of the opening, the slit, and lambda is the size of the wavelength. So they must be of the order of each other. Then diffraction is possible. But if the opening is much larger than the wavelength of the light, then the bending is almost unnoticeable. The diffraction doesn't take place then. So according to geometrical optics, when light falls on an opaque body, it forms its shadow of the same shape. And if no light enters into the region of shadow, or outside the shadow, the screen is uniformly illuminated. However, it is found that when light falls on sharp edges or small openings, then the light is bent, and the shadow of that light can be seen inside the geometrical shadows. This process is actually due to diffraction. Then there are two types of diffraction. One is Fresnel diffraction and another is Fraunhofer diffraction. In Fresnel diffraction, the source of light and the screen are at finite distance from the slit, whereas for Fraunhofer diffraction, the source of light and screen are at infinite distance from the slits, such as the rays reaching the slits are parallel to one another. So I can show the Fresnel diffraction and Fraunhofer diffraction diagrammatically here. Look, the slit and the screen are at finite distance uh, from the source of the light, whereas for Fraunhofer, the source and the screen are very far away from each other. Here is the table which will indicate clearly the differences between the Fraunhofer and Fresnel diffractions. You can go through this table in order to differentiate between the Fraunhofer and the Fresnel diffraction. Then there is a small important concept about the diffraction of the light waves from a single slit. Look, here is a single slit. The width of that single slit is AB, which is represented by D, such as the midpoint of that single slit is Q. Now, light rays are incident on the single slit with width AB or D, and two waves are considered, such as they are incident on the slit and they are interfering at point P after diffraction from this slit, such as this is ray 1, this is ray 2, and if we consider the path difference between this ray AP and ray QP, then the path difference will be calculated as d by 2 sine theta equal to lambda by 2. Here d by 2 is considered because this whole opening width is d and this distance is d by 2 because Q is the midpoint. So QA is d by 2, QB is d by 2. So we can consider either of them. So if I do consider the O point as bright spot, it does mean that the path difference will be followed as d by 2 sine theta equal to lambda by 2, such as I will get d sine theta equal to lambda or d equal to lambda by sine theta or sine theta equal to m lambda by d. So this is the equation for the diffraction from a single slit. Now it is also very necessary to understand the diffraction grating in order to understand the Bragg's law. So diffraction grating is actually number of parallel lines in equal width. They are arranged regularly in a uniform pattern, just like you can see in the diagram. So this shape, this structure is basically known as diffraction grating. Diffraction grating is consisting of a glass piece with a number of parallel opaque lines marked in on it. This is the transparent portion which acts as a slit. ये आप थोड़ा सा देख लें कि ये एक ग्लास प्लेट है और इस पे बहुत फाइन पैरेलल लाइंस जो हैं, क्लोज्ड फाइन पैरेलल लाइंस खींची हुई हैं. इन लाइंस के दरमियान जो आपके पास गैप है, वो गैप असल में एज अ स्लिट एक्ट करता है. सो वी कैन से लाइक द डिस्टेंस बिटवीन टू लाइंस on a grating is called grating element, and it is equal to length of the grating divided by the number of lines on it. The grating element is represented by D and is given by, so ये जो इन दो लाइंस के दरमियान स्पेसिंग है जिसको हमने D बोला हुआ है, उसको कैलकुलेट कैसे करेंगे? दिस फॉर्मूला इज यूज्ड विच इज यूनिट लेंथ ऑफ ग्रेटिंग टोटल नंबर ऑफ लाइंस. यूनिट लेंथ हम यूजुअली सेंटीमीटर की रेंज में लेते हैं. ये ग्रेटिंग जो होती है ये एक स्मॉल स्ट्रक्चर है. ये कोई हम मीटर किलोमीटर के हिसाब से नहीं लेते बल्कि सेंटीमीटर के हिसाब से लेते हैं, और उस सेंटीमीटर के डायमेंशंस में हम बहुत तंग नैरो और पतली पतली लाइंस जो हैं वो खींचते हैं. सो फार्मूला जो यूज़ होगा दैट इज़ फॉर द कैलकुलेशन ऑफ द ग्रेटिंग एलिमेंट एज 1 सेंटीमीटर डिवाइडेड बाय नंबर ऑफ लाइंस के. 1 सेंटीमीटर में हम कितने नंबर ऑफ लाइंस खींचते हैं, उसी हिसाब से दो लाइंस के दरमियान जो डिस्टेंस है वो स्पेसिफाई होगा. अब यहाँ पे ये आप देख सकती हैं हमने ग्रेटिंग उठाया हुआ है. ये एक लाइन है, ये दूसरी, ये तीसरी, ऐसे करके, और इनके बीच में ये छोटे छोटे स्लिट्स हैं जिससे लाइट रेज जो है वो डायफ्रैक्ट होंगी. और ये देखें आप, ये इंसिडेंट लाइट है और ये इस ग्रेटिंग पे फॉल होके डायफ्रैक्ट हो रही है, सच एज कि ये लाइंस जो हैं सारी मिलके जैसे पी पॉइंट में मिल रही हैं. हम दोबारा सपोज कर लेते हैं, इफ़ दिस P point is a bright spot such as the radiations or the rays coming out from all these slits and interfering at point P are constructively interfering here. So if all these rays are constructively interfering over here at P point, this means that the condition of the constructive interference is followed as d sine theta equal to m lambda. So such as the central maximum, this is equal to 0. So this is the 0 order. The first bright will be first order, and then the second order, and then the third order. And bright spots are also known as maxima because maximum intensity is obtained over here due to constructive interference. And the dark spots are known as minima because minimum intensity is obtained due to destructive interference. So if we consider all the bright spots starting from the 0 order, then the first order will be represented as d sine theta equal to 1 lambda, d sine theta equal to 2 lambda, such as finally we will be generalizing the formula for all the maxima as d sine theta equal to m lambda. This was all about the diffraction and some of the important concepts connected with the diffraction. Now we will be proceeding towards the important diffraction law, which is the Bragg's law. So here is the Bragg's law actually. Bragg's law is utilizing the diffraction of the X-rays from a crystal structure. Crystal structure is a regular arrangement of the atoms within a solid structure. The distance between the atoms is acting as the diffraction grating. That is the grating element, the distance d. जैसे हमने बात की कि हम डिफ्रैक्शन ग्रेटिंग पे पैरेलल लाइंस खींचते हैं इक्वल डिस्टेंस पे, और उन दो लाइंस के दरमियान जो डिस्टेंस होता है, जो स्पेसिंग होती है, उसको हम ग्रेटिंग एलिमेंट कहते हैं, जिसको हमने डी से रिप्रेजेंट किया। बिल्कुल इसी तरह से जब हम क्रिस्टल स्ट्रक्चर को कंसिडर करते हैं तो क्रिस्टल स्ट्रक्चर में एटम्स जो हैं वो बहुत रेगुलरली अरेंज्ड होते हैं, और उन रेगुलर अरेंज्ड एटम के दरमियान का जो डिस्टेंस होता है, उनके दरमियान की जो स्पेसिंग्स होती है, उसको हम ग्रेटिंग एलिमेंट बोल सकते हैं, डी से रिप्रेजेंट कर सकते हैं। सो थोड़ा सा एक्सरेज को समझ लें कि एक्सरेज आर शॉर्ट वेवलेंथ्स रेंजिंग फ्रॉम 0.1 नैनोमीटर टू 1 नैनोमीटर। इसकी वेवलेंथ यूजुअली अल्ट्रावायलेट और विजिबल से कम होती है। सो इसकी वेवलेंथ यूजुअली उस रेंज में आती है जो क्रिस्टल स्ट्रक्चर में एटम्स के दरमियान का डिस्टेंस होता है। सो जो डिफ्रैक्शन की बेसिक कंडीशन है कि द डिस्टेंस ऑफ द स्लिट्स मस्ट बी ऑफ द ऑर्डर ऑफ द वेवलेंथ ऑफ द इंसिडेंट लाइट, तो वो वाली कंडीशन इस स्ट्रक्चर से पूरी होती है। दैट्स वाई एक्स-रेज कैन बी डिफ्रैक्टेड फ्रॉम अ क्रिस्टल स्ट्रक्चर। सो अब हम सपोज करते हैं, यहाँ पे इस डायग्राम में थोड़ा सा आए कि सपोज देयर इज़ two incident X-rays, one is A whereas another is A prime, and they are incident on the crystal structure. This is the crystal structure, such as the incident ray 1 or A is incident upon the first plane, and incident A prime is incident on an atom in the second plane. So when this incident ray is incident on this atom, it will be diffracted in this direction, and the second incident ray A prime is incident here on this atom, and it is diffracted in this way. So now if you compare the two incident rays with the two diffracted rays, there are two path differences. One path difference is between the incidence of the rays, and one path difference is between the diffracted X-rays. Look here, BC is the path difference, is the difference of the lengths between the incident rays, and B prime C is the difference of the lengths between the diffracted rays. So when we will be confirming the conditions of the interference, then we will be calculating the total path difference, two times the path difference, one between the incident rays and another between the diffracted rays. So by calculating the two path differences, if we consider the triangle BAC, look, the triangle BAC, this is smaller triangle, and another triangle B prime AC. So for these both triangles, we can calculate the sine theta as BC divided by AB, and for triangle B prime AC, the sine theta is calculated as B prime C divided by AB. Such as the path difference for triangle BAC is BC equal to D sine theta, and the path difference between the diffracted rays is B prime C, that is equal to D sine theta. The path difference between the incident rays and the diffracted rays are very same, such as the total path difference is calculated as BC plus B prime C equal to m lambda. If we put the values for BC and B prime C in terms of D sine theta, so we will be calculating D sine theta plus D sine theta equal to m lambda, such as 2D sine theta equal to m lambda, where m is 1, 2, 3 and so on. So this equation is basically the Bragg's law, and that is utilized for the diffraction pattern of the X-rays from a crystal structure. So this is all about the Bragg's law. I hope you got it.